Hello, welcome to another episode of THP Tutorials. In this episode, we're looking at a practical session for operations management. That's the ninth chapter, capacity planning, right? So we're looking at how to calculate utilization and efficiency, right? So these are the formulas. Now, utilization is given by the actual output divided by the design capacity, right? Then the efficiency is the actual output divided by the effective capacity. And we've already talked about this in the theoretical aspect. So we're just going to dive right in, right? We have a question. We saw a few questions here. Look at what's next. So this question is on capacity planning, right? There that the Academic Computing Center has 5 trainers available in its computer labs to provide training sessions to students, right? Now assume that the design capacity of the system is 1900 students per semester, and the effective capacity equals to 90% of the design capacity, right? If the number of students who actually got their orientation session is 1500, what is the efficiency of the system, right? So in this example, we are finding efficiency. We understand that efficiency is for the actual output over the effective capacity. In the question, the actual output was what? 1500, right? And you know that because it was accompanied by the keyword what? Actual. Right? So this is what gives us the clue. Actual or actually got the orientation in 1500, right? So you can say that the actual output is 1500 students, right? So we need the effective capacity next, right? And the question didn't actually give us the effective capacity. It's gonna give us what? It's stated that the effective capacity is 90% of the design capacity, which was given us 1900. So to find the effective capacity, that would be equal to what? 90%, that's 90 over 100 times the design capacity, right? That gives us 1,710 students. So our effective capacity becomes what? This. Having our actual output and our design capacity, we apply for the efficiency. And we got to what? 1500 all over. Now check that out. Both are expressed as a rate. So we multiply by 100. Then answer in percentage, right? So when you do that, that gives you 87.72%. Right? It is the efficiency. And this is a pretty straightforward example. So let's look at a more complicated one. The results. Read the explanation. Example.
Sure.
Yeah.
I thought I would explain this, understand the utilization efficiency, what it is to us, because I don't really understand.
You don't understand?
Yes. The actual output. I've read it,
Well,
but I don't really understand.
you don't really understand.
Okay. If you can throw more light on it.
We talked about that in the theoretical session, but don't worry. Let's talk about that. Right? It's in the theoretical aspect, but for the sake of today, that's the sake of today. So utilization is what? The percentage of design. See, this is a ratio, right? Actual output to design capacity. So So to find the percentage of the design capacity that we are actually using. And then this, the efficiency is measuring the percentage of effective capacity that is actually used. And that's why it's actual divided by the design capacity times 100, right? I look for the percentage of the. So the design capacity that we set, how much of it do you actually use? Right? This question really answers for utilization. But if you want to find for utilization, so I'm going the actual output of 1500 all over the design capacity was what 1900 and 100, right? When you calculate this, what do you get? Yes. So yes, you know the calculator now. Right? So 1500 divided by 1900. Right, that gives you 0.7894. So times 100 will be 78.94%. Right. So this is to say that out of our design capacity of the 1900, we use 78.94%, which is what the actual. That's the actual percentage of the design capacity that we utilize, right? So the same goes for. So that's how you calculate it, right? If you want more clarification, you can just check out the class video and you understand everything. Or do you okay? So, Charles, example 2.
All right. The efficiency of a factory is 75%, and its utilization is 50%. If effective capacity is 1,509%.
Right. Thank you. So the efficiency is what? 75%. And then the utilization was 50%. It's just that if effective capacity is 1000%, find the design capacity, right? So it all boils down, so always come back to these formulas. We have been given effective capacity of what? 1000. Right? So you realize that we are spending what? Design capacity. We don't know the design capacity. Right? So how do you get this? We understand that utilization is what? Actual output divided by design capacity. But in this question, we do not have design capacity or we do not have actual output. We are only giving the utilization. Very good. So you can come to the efficiency formula. And that's given by actual output by effective capacity. Like that, we have effective capacity. We also have efficiency of 75, right? So you can use that and use to find for the actual output, which we then use for our calculations over here to find design capacity. So the first step would be to find for the actual output. Right. So actual output. So you just fix these values to the formula. Right. 75%. When you convert to decimals will be what? 0.75. Right. So 0.75 is equal to actual output. That's A. We don't know what actual output is. The effective capacity was 1000. So when you multiply this by 1000, what do you get? Right?
What do you get? Actual output.
That gives you 750. So you cross multiply.
So you do cross multiplication.
It gives you what? 0.75 times 1000. It gives you 750. So 750 is the actual output. Right? So this is step 1. What's step 2? Step 2, we come in.
You're going to give utilization.
This actual. So the actual. Now we have this also the utilization. So the same process. It's up to right? The utilization was 50%. So that's
0.5.
0.50 is equal to what? The actual output it was 750. It was 750.
So,
And then find the design capacity.
which is 1,000. Value for what?
Design capacity.
We don't have design capacity calculation. So you cost more price.
So why?
You said
So it's not because 750 divided by 0.5.
Yes.
are you okay, brother?
Yeah, I'm not. You want to
750
say
divided by 0.5.
0.5, 0.5, right? But this is what?
Yeah.
It gives us 1,500.
Right, 1,500.
What's your name?
Right. This is the idea for the
Pardon me, I have a question.
yeah.
At the beginning, you see, let N be both are expressed as a weight multiplied by 100. So when you express by 8, so you always give your answers in what?
Yes.
So how come? This one I find it this
The
okay.
design capacity. Alright.
Thank you.
Yeah. So
Okay.
let's look at this last example, which is a bit more complex. About it, please. You are the honest.
Hey, boy, yeah, I'm with you. Okay. I'm ready.
Yeah.
Yeah, wait.
A fleet verifies.
Mother, and the whole was you see it there. And then come on.
A fleet repair facility has the capacity to repair 800 trucks per month. However, due to schedule maintenance of their equipment, management feels that they can repair no more than 600 trucks per month. Last month, two of the employees were absent several days each, and they repaired only 20 trucks for 20 days in the month. What are the utilization and efficiency correction?
Alright. Thank you, Awadi. Thank you. So how do you go about this question? Right. Now, at this point, it's quite obvious that what this is very easy in terms of calculation, right? It's very difficult. It's very easy. And the trick or the hardest part to this kind of question is correctly identifying your design capacity, your effective capacity, and your actual output, right? So there's a general way. I mentioned this in the theory aspect, but design capacity is most of the time greater than effective capacity. Right?
Most of the time.
Most of the time. In most cases.
So please not every day. Not come and say
Yes.
so
So
I said every day.
if the design capacity would be lesser than the effective capacity, so you'll be able to tell it from the question. But in a normal circumstances, the design capacity is always greater than the effective capacity. And the effective capacity is also in turn always, most of the time, not always, most of the time, greater than the actual output. Right? So in a situation where you are supposed to find for all of these, and there are a bunch of figures in the question, you can just use this as a guide. Alright. So you have to find what? Utilization and efficiency. These are the formulas. Actual output by their capacity. Right? This is what actual output by effective capacity. What I said, the trick it lies with what identifying correctly these things, like Now, your question tells us that what? The fleet repair facility has the capacity to repair 800 trucks, right? 800 trucks per month, right? So, is the 800 the effective capacity or the design capacity, right? However, due to scheduled maintenance of their equipment, management feels that they can repair no more than 600 trucks per month, right? So straight away, you should be able to identify that what 800 is the design capacity, and the 600 is the effective capacity. But in the theory, yes, in the theory aspect, what did we say? So that the effective capacity is the output we expect the system to hold or to contain, given current operating constraints. Right? So it says that however, due to scheduled maintenance of the equipment, right? So the scheduled maintenance of the equipment is a constraint that you are currently facing. And that's why the 600 trucks per month is the effective capacity. But also uses the guided type, which we spoke about earlier, right? It is 800 to 600. This being greater is so the internet is greater than the 600. That can also guide you. Right now, you have to find out what the actual output. The actual output is what? Last 2 months, two of the employees were absent, right? 7 days each, and they repaired only 20 trucks per day for 20 days in a month, right? So every day, so for 20 months for 20 days in a month, they repaired 20 trucks each day, right? So if you want the total trucks that they repaired to what? The number of trucks they repaired each day and the number of days that they showed up in a month. So that would be what? 20 times 20. 2 times 2 is 400, right? So 400 is the actual output. So for utilization, that gives us what? 400 over 800 times 100. Then for the efficiency, now you can sort 400 over 600 times 100. So what does that give us? When you get to that point, the utilization gives us 50%. Obvious. It gives us 56.7%. Right. So that is for utilization and efficiency. Right. So now we'll look at the diagram, the diagram aspect of capacity planning, the diagrams involved, right? And the capacity analysis. We'll look at that. Capacity analysis, bottleneck time, throughput time, and all this stuff. We'll solve one example on that after our break. Alright, so we have a question here on the capacity analysis, right? We understand what the theory aspect then. This will help you understand more. It's a practical, right? So I have a question here. Let's ask the question. Question 3B. A certain production line has 4 stations, right? Station 1 can produce a unit in 8 minutes. Station 2 Station 2 has 2 identical machines, each of which can process a unit in 10 minutes. Each unit only needs to be processed on one of the 2 machines. Station 3 can produce a unit in 5 minutes, and Station 4 can produce a unit in 6 minutes. Right? So, we have to, one, represent the production line in a diagram and compute the capacity of each station. Right? 2, Which station is the bottleneck station? We explain. 3. What's the capacity of the production line? And 4. Compute the throughput time. Very good. So, how do we start? Now, the production line has what? 4 stations. Four, right? Now, station 1. Right. So that will be, I'll make a S1. S1 has produces a unit of a unit in what 8 minutes, right? So I have eight minutes per unit. 8 minutes per unit, right? And station 2 has 2 identical machines. So that's 2 machines. And it's 10 minutes. 10 minutes per unit. Like, what does this mean? You know, like station 2 has 2 identical machines, each of which can process a unit in 10 minutes. Right? And it further states that each unit only needs to be processed on one of the 2 machines. And so the machines are parallel. They're not processing one unit together. Each unit is producing this thing. Each machine is producing a unit in 10 minutes. So it's just the 10 minutes, right? Because they're not working together. The 10 minutes. So the station 2, we're not going to do 10 plus 10. It just be 10 minutes. Right. Now station 3 can produce a unit in 5 minutes. And station 3 5 minutes. Okay. And station 4 does what? Can produce a unit in 6 minutes. I have to do this. So it's quite simple, right? You have station 1. This side to go down. And you indicate here that what? 8 minutes per unit. Right? And then station 2, remember, had 2 machines, 2 identical machines. So that's it. Yeah, let's make this judgment 2 because look of them. And station 3 had 5 minutes, right? And then station 4 was 6 minutes. this is how it's going to look. Alright, so if it's done from station one, if the unit is done, one goes here, one goes here. So just 10 minutes over here. So this is how we represent the diagram. We use the eye. Right. To compute the capacity. Yeah.
Is there why did you do that? Why did you do it?
Oh, yeah.
No, but okay, no, Max, is there a reason why you did like this? The diagram like this? Yes, that is something that should be like this.
I'm trying to capacity.
I don't understand what you're saying.
That's
Right. What about?
I tried to explain. You do S1.
Yeah.
S2. Why you say you do it like that?
Like, how
Can I say, call for the
Hey,
carry my card?
why you do it like that?
Hey, yeah,
That Jimmy,
hey,
but why you do it like this?
we have to diagram. So
you can do it anyhow. Or you have to do that.
Yeah. You see that? Station one. What I've done. When a unit leaves here, to go to station two. Yeah, but I take this one away. How this one do? This right? No, it does not make sense. But it's like this is stating clearly out. When you list station one will go here. Any of them, right?
That's true, I think.
Two identical machines. Right? So when you can either go here or go here. Right? You spend 10 minutes that way. You have to the station 25 minutes before.
Right. Jobless.
So, right. So now tell us to compute the capacity of to represent the production line in the diagram. This is the diagram. And the next thing was to compute the capacity of each station. Right. So the capacity of each station. So to get the capacity of each station, that will be what? You know, the capacity is measured in hours, right? So the capacity per hour is what you have that's 60 minutes make up 1 hour. Right? So 60 times 1 hour, that's 60 minutes. So that's how you have 60 minutes here. The time taken to complete the unit is per station, right? So station 1 had 8 minutes to complete, uses 8 minutes to complete 1 unit. So completing that, when you end of the station 2, you don't do 10 plus 10. Right? So just take 10. So it's divided by 10. So these are their respective capacities. Bear in mind, this is what per hour. That's how we measure it. If your question was in seconds, but not 60 seconds times 60 minutes, because 60 minutes make up 1 hour. That gives you 600 seconds. And this one is in minutes. The next question was to state which station was the bottleneck, right? And the bottleneck is what? The station with the slowest processing time, or the longest time, right? So from here, it's that's station 2. So station 2 is the bottleneck. And you extend out. It is a bottleneck because it takes the longest time to process a unit, or it has the slowest processing time. That's why station 2 is the bottleneck for 10 minutes. Like this, 10 minutes, right? The next question was what? What's the capacity of the production line? The capacity of the production line is the capacity of the longest bottleneck. The capacity of the bottleneck. Isn't it? So the capacity of the production, this entire production line, is the capacity of this one. The same 6 units per hour. Just you always find the bottleneck. So the capacity of the bottleneck, the capacity per hour of the bottleneck, the capacity per hour of the entire production line. That's how it will. Let's see that. Now you have to compute the throughput time. The throughput time is the time amount of time it takes towards the amount of time it takes per unit from the start of this production to this finish. So how do you get that? That will be 8. You cannot do 8 plus 10 plus 10. This is just one thing. Now in a situation where they have different processing times, you have calculated for one part. So you have done what? 8 plus 10 plus 5 plus 6. This is 11. 10, 21, 8, 29. So this is what 29 minutes. 29 minutes per unit. That's the throughput time. 10 minutes per minute. But assuming that, so in actuality, what you should do is just, after you find for this first part, and after you find for this part 2, to be the same 29. So 29 will be your throughput time. But in some questions, you might have what? Like you saw in a practical, in a theoretical aspect. Sometimes the question might state out there are 2 different processes going on here. And this one can be like 15 minutes. You still add one part, add the other part. And then you take the one with the longest time to the throughput time. Right. So that's it for capacity plan. Thank you very much for watching. Please don't forget to like and subscribe. And if you haven't subscribed, please make sure you hit the subscribe button and help us get to 400 subscribers. Thank you very much.